First one, MCQ, which one is not base quantity? Which one is not base quantity? Area, because this is your area, the units will actually be square meters. So it is made out of length times length. Okay, what about length? Of course, it is going to be m lah. Mass, kilogram, time in seconds. So answer is A. Base quantities, they are your basic types of measurements that everything else is based on. Okay, so as long as you have your base quantities, any other thing you can express them in terms of your base quantity. For example, your volume, you can express it in terms of length times length times length. Speed, you can express it in terms of length divided by time. So meters per second, M and S. So many more lah. Okay. Next question. Which one is the correct SI units? Density is actually kilogram per cubic meter. So C is wrong. Okay. Oh, which is the correct one? Sorry. So D. Only D is correct. Arif, sit up. What is the reading shown by the vernier calipers? How do we do it? First, we find this 0 mark, right? We need to read this value. This is 7.1 something. So we need to find the something. Over here. 5, 6, 7, 8. So 7.18 cm. So answer C. Question 6. Micrometer screw gauge. Yesterday I made you guys do this, right? What is this value? 15. 5. This is 16. 16.5. 17. 17.5. Plus 0 point something. What is the something now? Over here. 26. Answer 17.76. Okay. Yes, thank you. 17.76. Answer is C. Question 8. Okay, average speed equals to, what's the formula? Shufi? Distance over time. Is it? Winnie, can you improve on answer? Okay. Okay. Correct or? Correct? What's wrong? Arif, what's wrong? Anything wrong or correct? We need to include 10 seconds. So you get 180 divided by 45. man runs along a straight path, go this way, 80 meters, turn back, another 10 meters. Displacement from the starting to the ending. So this must be 80 minus 10 equals to 70. Highest acceleration, okay, speed time graph, so gradient equals to acceleration. Area under graph equals to distance traveled. So we want the highest acceleration, meaning highest gradient, meaning most steep portion. There are 4 portions over here. Which one is the most steep? Zafira, which one most steep? B, yes. It is most difficult to climb this slope. So answer is B. A ball is dropped from a height. Okay, keyword drop. VI, initial speed equals to 0. Take 5 seconds to touch the ground. This is the speed time graph. So, gradient equals acceleration. Area under graph equals distance traveled. Just keep writing this, you will remember it, you'll memorize it when the time comes. Okay? So, looking at this graph, is it a straight line? It's a straight line. It's not a curve. So straight lines have a constant gradient. So over here, there's a constant gradient, telling you that acceleration is constant. So this is what we can tell so far. Which one is not correct? This is correct, acceleration is constant. The height is 250 meters. Height is given by the distance traveled. The height that the ball was dropped is the distance it covered, right? So the distance covered must be the area. Let's see what is this area. Area of triangle. So distance traveled equals to half times base times height, 50. So this is 250 over 2, 125 meters. Oh, so this is wrong. The height was actually 125. Okay, so answer is B. What about A? The height increases by 10 meters every second. Yes, that is true. That is what we call the acceleration due to gravity. 10 meters per second in 1 second. So look at the graph. At time equals to 0, speed is 0. Time equals to 1 second, the speed increased by 10. In another 1 second, the speed increased by another 10. Another 1 second, increased by another 10. So that's our acceleration due to gravity, 10 meters per square second. Alright. The speed of the ball just before hitting the ground is 50. We hit the ground over here. The speed is 50. So this is correct. Distance time graph. Constant speed. Why got two answers? This one also ba? The distance is because distance cannot decrease. Only your displacement can decrease. Your distance traveled cannot get smaller and smaller. So, nope, we don't accept this. Answer is B. Okay, speed time graph again. So, gradient equals acceleration. Which one is correct? Acceleration at L greater than M. Acceleration at L meaning we want the gradient at L lah. This gradient and this gradient, are they the same? Yes, it is one straight line. So the gradient is the same. It's wrong. Acceleration is constant, meaning same. So this is wrong. Huh? Displacement is decreasing. The speed is decreasing. But does that mean he's going backwards? No. I can be running to the door. My speed decreases. I am still heading towards the door. Okay? So, nope. The distance traveled is decreasing. Also wrong. The speed is decreasing. Yes. So, maybe at 1 second, the speed is so much. S1. After 3 seconds, the speed has decreased. Finally, at time equals to, 5, the speed is now 0. Owen, what's the resultant force on the box? What's the resultant force over here? Hey, you Owen. What did you write as your answer? 8. Now that correct? Why it take so long? So 10 minus 2, you get 8. Object falling 10 meters per square second. This is our acceleration. Mass is 2 kilograms. Okay, the object falling down. Resultant force, F, resultant equals to mass times acceleration resultant. So this is 2 times 10, 20 newtons. This is our resultant force, also known as weight, which is equals to mg. Not the effect of the force on the body. B. 17. Constant velocity again. Who did I ask just now? Constant velocity. Shafi, was it you? Did I ask you about constant speed? Okay, tell me again. Resultant equals to 0. What does it imply? What does this imply? Oh, I asked somebody else just now, right? Winnie. What does this imply if the acceleration is 0? Okay. So F resultant equals to M A resultant, which is equals to 0. Sure? What's the mass? Okay, 20,000. What's the acceleration? What did Shufi just say? 0. So equals to 0. Yeah, you were correct. I just challenge you a bit, then you not sure already. So A. Metal cube, 100 newtons. This is the force. Each side 10 cm long. So cube is 10 cm, 10 cm. So pressure is the force over area. Look at all the units here. Newton per square meter. So over here, square meter. One side 10 cm, right? This is 0.1 meter. So the area is 0.1 times 0.1. Answer D. Zafan, do you get this? What do you put as your answer? Did you also put D? Or you left it blank? Okay. So I will say it again. Pressure is force over area. Force is 100 newtons. Don't need to change. Area 0.1 meters times 0.1 meters. Because all the answers are in square meters. So if you had used 100 divided by 10 times 10, you will get A, which a lot of students made a mistake. Okay? Okay, now let's measure the thickness of one sheet of paper. How to measure? What's the instrument with the highest precision that you know? They use the micrometer screw gauge. But in this case, we are going to use perhaps vernier calipers, because we see that there are 2 decimal places for centimeter. So we know that he used a vernier calipers. Okay? Because if you just use your ruler, right, you only can go up to 1 decimal place for centimeter. Okay? So calculate the average. You just add everything up. Divided by 3. Statement is equals to 1.18. Thickness, average thickness of one sheet of paper, then we're going to divide this by 50 lah. So average thickness equals to 1.18 divided by 50. And we get 0.023 6 exactly. Sorry, 0.023 236. Okay, next. Why does he need to take 3 sets of reading to measure? To improve accuracy, we take average. So that is the standard answer. Okay? To obtain an average reading so that it will be more accurate. You're done. Think about how you can improve it. How can we improve the experiment to get a more accurate thickness of one sheet of paper? Simple. What do you think? More than 3 times, is it? So she measured it 3 times. So Simon is saying, take more than 3 readings lah. Yes, you can do that. Any other way, Owen? Any other way? Measure just one sheet. Measure just one sheet is the worst way to do it. No, we want to improve it, not make it worse. You cannot get a very accurate reading or precise reading if you just measure one sheet. That is why we measure 50, and then we divide. The errors that we get, we divide it by 50 so that the thickness is more accurate. So going by that logic, if I want to make it even more accurate, should I use more paper or less paper? More paper, right? So the other way of improving it is to use more than 50 pieces. So we can take more than 3 readings or measure more than 50 pieces. Next, pendulum clock from X to Y, 0.15 seconds. What is the period? What is the time for one oscillation? Nancy, what do you think? Okay, 0.15 plus 0.15, 0.3 seconds. Because it needs to go from X to Y, then back to X. That is one complete oscillation. So 20, it will just be duration equals to 0.15 times 20. So you get 6.00 seconds. While waiting for his friend, he counts the oscillation. Friend arrived in 3 minutes. Okay lah, 3 minutes equals to 3 times 60 equals to 180 seconds. So for one oscillation, you take 0.3 seconds. 180 seconds, you will get 180 divided by 0.3, and amazingly, he counted from 1 to 600. Very unlikely lah. Okay, now the clock not accurate. He wants to slow down the pendulum clock. What can he do? Whenever you have a pendulum, you want to make it go slower. Increase what? Okay, increase the length. Any other things that we can do? Can we change the weight of the pendulum? Yeah, because you change the weight, it doesn't affect. Only your length changes the period. Right, Junior? Right? What are you doing? Huh? What? You all thought at the same time I cannot hear. Our correction. What did you do on the table? Okay, question 3, plot. Okay, your graph should look 3 and 6. I need to see all your crosses. Right now, I'm not drawing it. Okay, so this is for A, this is for B. Which car has a higher speed? From 0 to 4 seconds. Higher speed. This is your distance time graph. Your gradient is your speed. The one that has a higher speed has to have a higher gradient. So which has a higher gradient, A or B? B. Next, at what time did B overtake A? See, B actually started 1 second later. That means A already started traveling. Then B started. So B is behind A for a long time until he overtakes. So when did he overtake? What happens when you overtake somebody? That means you are at the same place at the same time. Where in this graph you have them at the same place and the same time? This intersection point. At this intersection point, A and B are at 6 meters away from the starting at time equals to 3. So time is 3. Any questions? Please, yes. How come what? Why will you overtake at 0.1 seconds? Why do you think so? They are same place, same time. Then? Hey, no, we must clarify this. What is going on in your mind? Yes, exact same location. Oh. So you are suggesting is 0.1 seconds after 3 seconds, is it? Then why not 0.001? How about 0.0001? Even better, right? That means you are thinking the word overtake means go past, right? I mean, logically, that's what it means, overtake. But in physics, right, we take it to the point where they meet each other already. Because how precise do you want it to be? Like I told you, 3.0001 is even better. How many zeros are you going to put in between? As many as you can. So eventually it's going to be equal to 3. Okay, long question. Name force A and B. This one is in contact with the ground. This must be all friction. A. What do you think it is? Okay, air resistance. Part 2. Total amount of force A and B is 500. Okay. These two, 500. Then there's a forward driving force. Calculate the acceleration of the car. What is the resultant force? You have 500 behind, 5,000 in front. Resultant force is 5,000 minus 500. Okay, this is your resultant force. The forward driving force, of course, is going to be greater than all your resistance. That's why you can accelerate forward. Okay, so keeping that in mind, okay, now again, I'm going to ask Winnie, what is F-hour equals to? Equals to MA. So M times A, where your A is your acceleration. Do we know the value of F-hour? Yes, it's 4,500. So 4,500 equals to mass. How much is the mass? 2,500 kilogram times your resistance. So AR is equals to 4500 over 2500. You get 1.8 meters per square second. This means that the car is increasing its speed by 1.8 seconds every 1.8 meters per second every second. Alright, next one, part B. This is a speed time graph. So gradient equals to acceleration. Area under graph equals distance traveled. What's the distance traveled by the car from Q to R? Q to R. So we are interested in this area. Every single one of you can tell me and calculate what is the area of this triangle, because this is 15. There you go. What did I do? Okay, this over here is 15. So distance traveled is equals to half times 15 times 15. Or if you want to be more clear, it is 17 minus 2 times 15. And the distance will be 112.5. Okay? So deceleration of the car. That means the speed is going downwards. Talking about this region. Deceleration. Deceleration equals to negative acceleration. equals to negative Vf minus Vi over T. What is our final speed? Final speed 0. Initial speed 15. Time taken 15. Sorry, this is 15 seconds. 15 seconds. So final speed was 0 minus 15 divided by 15 seconds. So 1 meter per square second. Am I giving you all enough time to copy the corrections? Ready? Okay. Then now a parachutist. Wow, so many. Initial acceleration. So the gradient over here. Initial acceleration will be 10 meters per square second. Because anything that you drop, I drop my phone, it's going to drop with an acceleration of 10 meters per square second. I drop my bottle, same thing. Okay? It is only as it travels down, the speed actually, the speed increases, but the acceleration decreases. Okay, let's see what happens. So the acceleration, look at the gradient. This is very steep, right? As time passes, it is less steep. As time passes even more, even less steep. So the gradient gets smaller and smaller. What does that tell me about the acceleration? Yes, acceleration is decreasing, not, it is not deceleration. This is wrong. Acceleration is decreasing. Do you know what deceleration is? Yeah, it is the speed decreasing. Okay, so acceleration decreasing is totally different. What time does your lesson end? Okay. Okay.